Okay, our objective today is to start chapter 9. In particular, we are going to explore square roots today. So from the SMART slide of chapter 9, what do you think the entire chapter 9 is going to be about? Kevin?
Squares.
Oh yes, squares, right? Those are all squares. If you say that, I think we need to go back 2 grades, right? So based on the SMART board, what is all of chapter 9 going to be about, Ben? Good, real numbers and, Neil? Good, right triangles. So before I start with this, does anyone know anything yet about a triangle? Go ahead. Yes, we are. We're going to learn about Pythagorean theorem. Yes, it's exciting. Ben? Good, triangles have 3 sides. Great, what else? Camille? Say that again. Awesome, 3 vertices. They have 1 here, 1 here, 1 here. What else? Neil? Awesome, good job. Man, you guys know a lot about this. David? That's not the area. That's how many degrees are in a triangle. So you're correct. There's 180 degrees in a triangle. Exactly right. Right? They're pointy. Very good. That was obvious, right, Peyton? Good job. Who knew that? If it's a right triangle, the side opposite the right angle is the hypotenuse. Raise your hand if you knew that. Okay, so you guys, half of you. If you don't know what a hypotenuse is, we'll get there. Grace, did you guys learn that last year at St. Sebastian? Okay. So this red side here is called the hypotenuse, and we'll explain more about what Pythagoras found and how he found it. I have a little activity that we'll do to show you how Pythagorean theorem really works once we get there. Neil? Yep. Or obtuse. Good job. Ray? Yep. David said that, but that's okay. You probably didn't hear him. Camille? Good job. Justin, you'll see it sticking up. Good job. Base times height divided by 2, or 1/2 base times height. Areas, units are always inches squared, meters squared, centimeters squared, etc. Ben? Not true. Kevin? Hey, Justin, yellow folder. Okay. Sorry, say that again, Kevin. Most triangles are what shapes?
Shapes.
Oh, jeez. Ray? Yep, good job. Okay, one more. Peyton? Yes, very good. Yeah, one more. Okay. All right, lesson 9.1. So we're going to focus in now on how to find and how to approximate square roots of numbers. So if this is an intro, because you need to know what a square root is, you also need to know what your perfect squares are. Why didn't you do this? You also need to know what a perfect square is, especially for the next lesson. So that's why your warm-up was extremely important today. So we're going to talk through that, and I'm going to let you know what you're going to need that for and how I would like you to learn those. So let me start with, on your calculator, does everyone know where the square root button is? Okay, I want everyone to open up your calculator if it's not already. Let me get mine up. Drew. Okay, on your calculator, who can tell us how do we get the square root symbol up if we want to find the square root of something? Amberly? Good. Second x squared. So let me show you that again in case you didn't hear her. Second x squared allows you to get the square root symbol. We're going to need that for today. So did everyone find that on their calculator? So let's just pick. I'm going to say let's type in 25. If we want to find the square root of 25, which, yes, it is a perfect square, which I'll explain more in a second. Drew, what do you get? Good. So hit enter, and your calculator will solve and give you square roots. Now, this lesson we're going to use our calculators for, because it's an intro to the chapter. However, tomorrow, we're going to simplify radicals, which are square roots, without the calculator. Okay? Ben? Well, you probably forgot to do second x squared. Okay, let's go back to our lesson. So getting into the first warm-up here. So you guys had to answer, if the area of a square is 16 inches squared, find the length of each side. How do you do this? Joseph? Good job. We know the area is 16 inches squared, and Joseph's right. If we just take the square root of 16, you end up with, Drew, each side is what? Good job. Each side of the square is 4 inches. How do we really know that? How do we know that? Grace? Awesome. Very good job. The area of a square is side times side, or you could say length times width, however you want to say it. 4 times 4 is 16, which is the same thing as saying you just need to take the square root of 16. You get the side as 4. Ben? What do you mean, what if it's not 4? Then this would not be 16. Okay. Anyone else? All right, let's go to the list of perfect squares. Hey, where'd it go? There we go. I must have skipped a slide here for a second. Okay, let's go to the list of perfect squares here first. So David, 0 squared is? Good. Greta, 1 squared. Good. Evan, 2 squared. Camille, 3 squared. Mike, 4 squared. Ray, 5 squared. Josh, 6 squared. Skylar, 7 squared. Grace, 8 squared. Good. 9 squared. Drew. 81. 10 squared. Jackie. Good. 11 squared. Michelle. Good. 121. Peyton, 12 squared. Good. Nathan M, 13 squared. Did you not do your warm-up? Oh, yeah, that's right. Thank you. 169. 14 squared. Neil. Good. 15 squared. Kevin.
225.
Good job. 30 squared. Grace. Good. Alexis, 50 squared. Good job. 2,500. So we're going to make one more list, and we're going to be going backwards. So at the top of your notes where it says objective, I want you to make one more list with me. We're going to go backwards, and I'll show you what I mean. And then we're going to talk about why we just did this. Okay, so at the top of your notes where you have room, I want you to write down square root of 1. So at the top of your notes where you have room, I want you to write down square root of 1. Okay, Greta, square root of 1 is 1. Okay, let's go to the second one. Square root of 4. Joseph. Square root of 4. Careful. So in other words, what times what is 4? Good. Michelle, square root of 9. Good. Evan, square root of 16. Good job. Alexis, square root of 25. Good job. Mike, square root of 36. Good. Skylar, square root of 49. Good. Square root of 64, Josh. Good. Ray, square root of 81. Good. Square root, Drew, of 100. Good. Grace, square root of 121. Good. Square root of 144, Jackie. Good. Square root of 169, Camille. Square root of 169 is, good, 13. What do you think the next problem is that I'm going to ask you about? I'm going in order. I'm sure you realize that. Amberly? Good. Square root of 196, which is 14. What's the next one going to be? Square root of Peyton? Good. Square root of 225, which is 15. And let's stop there with that list. Okay, so I went backwards. I want you to practice having these memorized, going both ways, from 1 through 15. So we did the other list as 15 squared is 225, 12 squared is 144, 11 squared is 121, etc. I also want you to know it from this way. So if you're given a square root of a perfect square, these are the first 15 perfect squares. Does anyone know why these are perfect squares? Mike, why are they perfect squares? Good. Their square root is a nice or perfect number. So in other words, the square root of 4 is 2 because 2 times 2 gives us 4. The square root of 9 is 3 because 3 times 3 is 9. If you take the square root of an integer and you get a nice number, you know that number inside the radical symbol, which is your square root, is a perfect square. Extremely important that you know what a perfect square is for tomorrow's lesson. Any questions on those? So I want you to make sure you know the list both ways. Now, yes, we could keep going. We could go 16 squared, 17 squared, 8, etc. We could keep going, but we're not going to. Ben? Go ahead. Yeah, but there's not a check mark by the answer. Oh, you mean that the square root symbol looks like a check mark. Is that what you're saying? Well, it's not a check mark. It's the square root symbol, the radical symbol. Okay? All right, so let's go back to some definitions. So underneath that first warm-up, the first definition we need to talk about is square root. So we already have had an introduction of it. So let's now make sure you guys write down that from your book, a square root is of a number n is the number m such that m squared equals n. So a square root is a number m such that m squared equals m. I should not be doing this right now. It should be right here. I know it is. That's why I like to start off with talking about it first. They like to throw all these variables in. So a square root. In other words, what they're trying to have you get from that is that the square root of 9 is 3. Ben? No, the square root is what that's equal to. Okay? All right, second one, perfect square. We already talked about this as well, so the definition should make more sense. A number that is the square of an integer. A number that is a square or the square of an integer. For example, square root of 100 is 10. We just went through on our second list the first 15 perfect squares, so you want to make sure that you know those. Really beneficial for this whole chapter. When you take the square root of a nice number, you're going to get a nice number, then it's a perfect square. And then one more, I know this is not in your notes, so wherever you have room, I want you to add in, please, radical expression. And we're going to simplify some of these today. Wherever you have room on your notes, radical expression is an expression that uses or involves a radical symbol. In algebra next year, if I have you guys, I usually get to chapter 12 with the 7th graders. That's what we're going to get to this year. We will start to simplify and solve equations that have radicals in them. For this book, for this year, we're just going to talk about radical expressions. And you should remember from chapters 1 and 2 that an expression does not have an equal sign, an equation does. So radical expression, an expression that involves or uses a radical sign. Greta? Yes, very good. Square root of 16 is 4, and then 4 plus 1 is 5. Very good. And when we solve these, or simplify them, I should say, you still need to follow order of operations. A radical symbol, which is your square root symbol, you can consider a grouping symbol. Okay, because there's going to be things in it. So you always want to simplify that first. All right, let's do some examples. So underneath the box of perfect squares, Roman numeral 1 says, find the square root of each number. If necessary, round to the nearest hundredth. Your homework's going to be kind of like this. Determine whether each of the numbers is a perfect square. So I want you to take your calculator, type in second x squared. I'll do one of them with you. Second x squared. Justin, are you done? Okay. Second x squared, 222. Hit enter. Did everyone get 4.9? If we round to the nearest tenth, just want to make sure your calculator's okay. 14, not 4, sorry. 14.9. Okay, is that a perfect square? No, so not a perfect square. Is that a rational or irrational number? Irrational. So I want you to write underneath it, this is an irrational number. And you could also say it's not a perfect square. So it's an irrational number. Remember, irrational is like what? What did I always used to relate that to, Grace? Good, pi. It just goes on hover at once, it repeats randomly. Irrational. Okay, what about negative square root of 169? You should, some of these you should know, or if not today, by tomorrow, hopefully. Amberly? Good, negative 13. Is that a perfect square? Steve? Okay, do you know why? Yeah, even though it's negative, you were confused about the negative, right? Even though the negative's there, the square root of 169 is a nice number. You're still getting an integer, so I want you to put, yes, this one is a perfect square, because the square root of 169 is 13. The negative in front means you just throw that negative in front. Is that rational or irrational? Ben, rational or irrational? Good. Can you explain why? Good job. Is that a whole, natural, or integer? Or all of them? Whole, natural, integer. Amberly? Nope. That's okay, though. Yeah. Okay, close. Gerda? Okay, why? Good job. Remember, only natural and wholes, the natural numbers and whole numbers do not include negatives. An integer does. It's a nice number. It includes all negatives, all positive, and 0. Why am I bringing that up right now? Just to review, because you'll see that again for your final. So it's the only reason I brought it up. Okay, let's go to letter C. I want you to type in, we'll do a couple more of these. Type into your calculator square root of 351.56. Good, if you didn't already. And I want you to write down whether it's rational or irrational. Fast. You guys are fast. Oh, that's okay. That's okay. It's all right. You guys are fast, though. Okay, what is the square root of 351.56, Kevin? Good, 18. I'm going to round to 18.8 since it said to the nearest tenth. Alexis, is this a perfect square? Oh, did it say hundredth? Thank you. Yes, it does. Thank you. Alexis, is it a perfect square? Good, not a perfect square. So Alexis, is it rational or irrational? Good. Irrational, it is not a perfect square. So 18.75. Again, we rounded that. It really keeps going however it wants. Okay, I want you guys, some of you already did this, go ahead and finish letters D through H. Some of you already did. If you already did finish, that's fine. Just wait patiently. After you take the square root, if it's a perfect square, write down perfect square. And then either rational or irrational. Give you a couple minutes. Bless you. No. That was just a review. No. Okay. Oh, why didn't you didn't get a note packet?
Oh, no, I'm trying to take one.
Oh, okay, that's fine. That's fine. You'd rather use that though, right? Okay. Yeah. Wait, what'd you say? Yes, it'll be a nice number. Yep. Okay, Drew, letter D. What's the perfect square, and is it rational or irrational? Okay. Good. Ray, letter E. Good. Good. Perfect square. Rational or irrational? Good job. So perfect square, rational. Skylar, letter F. Good. Perfect square. Good. Rational or irrational? Good job. Perfect square and rational. Questions on those? Okay, Jackie, letter G. Good. Perfect square. Good. Rational or irrational? Good. And Evan, letter H on that page. Good. Rational or irrational? Great job. All right, so that's pretty easy, right? Any questions on that page? Okay, flip over. Let's simplify some rational expressions. So letter I, and this is all in part 2, says evaluate each radical expression when a equals 4 and b equals 16. So all we're doing here is we're plugging in numbers. So we need to plug in a is 4, b is 16. Remember, when numbers or letters are right next to each other, you need to multiply them. So we have 4 times 16. What is 4 times 16 without your calculator, Kevin? Good, 64. Without looking, without the calculator, what is the square root of 64? Grace, good job. That is a perfect square. 8 times 8 is 64. You know the square root of it is 8. Okay, second one, -4. And then in the radical symbol, we have b minus a. So 16 minus 4. So we're going to subtract first. We have -4 square root of 12. Now, this is going to bother me because tomorrow I'm going to teach you how to simplify this without the calculator, which is how you should do it. But your book wants you to start off with simplify square root of 12 on your calculator, hit enter, and then multiply that by -4. A number in front of a square root symbol, which is your radical symbol, is kind of like having a number in front of the parentheses. You just multiply them together. So after you take the square root of 12 and hit enter and times -4, what do you get? Kevin, what do you get? 13. Good, -13.86. And that was because the square root of 12 is about 3.46. And then you multiply that by -4. So pretty easy, just be careful, take your time. Tomorrow, we're going to keep it the way you should keep it when you solve Pythagorean's theorem, which is simplify the radical to keep your answer exact. This is an estimate. We're rounding, so it's not the exact answer. It bothers me, but we need to start learning it this way first. Okay, letter K, square root of a over b. So let's plug in what we have. A is 4, b is 16. How do you think we simplify that? Anyone have any idea, Amberly? Okay, how'd you get that? Good. So we can take the square root of each of them, and I'm going to separate them. Bless you. The square root of 4. Amberly, what's the square root of 4? Good. And then the square root of 16 is 4. Good. So the first step is take your fraction, put the square root symbol around the numerator and around the denominator. They both end up being perfect squares. So you end up with 2 over 4, which is 1/2. Or you can write it as 0.5. Drew? Yeah, you can put it in your calculator. Yeah, but I also want you to know how to do it by hand. But yeah, you can do it in your calculator too. Okay, last one on here. Square root of a squared plus b. So let's plug in what we have. A is 4, b is 16. What do we need to do first on this one? Mike? Good. So Mike, what is 4 squared? Good. So we have 16 plus 16, which is 32. Is 32 a perfect square? No. So what is the square root of 32? Camille? Good. 5.66, and that's rounding. So your answer to that one is 5.66. Questions on any of those? Okay, let's go to Roman numeral number 3. Okay, Roman numeral number 3, sorry, I can't talk, is using square roots to solve equations. These are extremely basic and easy equations, but they're throwing square roots into it for you. So first one, t squared equals 25. How do we get rid of the square, which is your exponent? How do we get rid of that? Grace? You need to square root both sides. A square root undoes or gets rid of an exponent of a 2. And I'm going to tell you why, but I hope this doesn't confuse you. Square root is the same thing as putting something to the 1/2 power. So here's what happens. A square root of t squared, this cancels the 2 because t squared to the 1/2 power, 2 times half is 1. I don't know if does that make sense to anyone? This is something you won't learn until Algebra 2, but I figure I should tell you. So that's how you just get t to the first power, which is just t. Taking the square root of something is really raising it to the 1/2 power. Not something I'll ask you on your test, but something to keep in mind. So when you get to Algebra 2, it's in Chapter 6. You'll remember, like, oh yeah, we learned that. Square root of 25 is 5. However, we need to add something to our answer. T squared. There's another answer. Yes, 5 squared is 25, but what else squared is 25? Neil? Steve? Nope. What else? So 5 squared is 25, but what else squared is 25? Joseph? Say it again. T? No? Neil? Yep. So -5 times -5 is positive 25, right? And 5 times 5 is 25. Now, how you should write your answer is, so these are the two different answers. You should write it as t equals plus minus 5. Have you guys seen that plus minus sign symbol at all? There's a plus sign on top, minus sign on the bottom, to indicate there's two possible answers. Because you know if you're squaring something, whether it's positive or negative, you're still going to get the same answer. Does that make sense? Okay. Second one, Mike, how do we get rid of the square? Good. So let's square root both sides. Remember, square root is like putting something to the 1/2 power. Square root of a squared is just a. Without looking and using your calculator, what's the square root of 225? Grace? Good job. 15. Remember, there's two answers because anything squared gives you, in this case, 225. There's two answers. What's the other answer? Alexis? Good. -15. And then how I really want you to write your answer is a equals plus or minus 15. And that's only when you're solving an equation like this. And I want you to try to remember this. I probably won't take off on a test, but try to remember there's two possible answers. Okay, letter O is a little different. What do you need to do first on this one? The two-step. Camille? Good. First thing we need to do here is divide by 8. So Kevin, what does our second step look like?
You get 16.
So n squared equals 16, okay? Good job. So we get n squared equals 16, and then we need to square root both sides. Remember, the square root cancels the exponent of a 2. And Drew, we get two answers. What are they? Good job. So I'm going to start writing them as one answer. We get, even though there's two, we get plus or minus 4. David? Yeah. Plus or minus 4 as your answer. If you're squaring a positive or a negative, you still get a positive. All right, let's try two more. Letter P. Think back to chapter 2. Ray, what's the first thing we need to do on letter P? Nope. Careful. Good. First thing we need to do is subtract 2 on both sides. So minus 2. So we get x squared equals 7. Now, is 7 a perfect square? No. So at this point, you guys can go ahead and simplify it to a decimal. We're going to square root both sides. Get rid of your square on the x. So x is equal to plus or minus, what's the decimal, Amberly? Good, 2.65. Remember, plus or minus, because when you square it, it's going to be positive either way. Okay, I want you to do letter Q. So try letter Q. You should get a decimal on this one as well. Right there. Yep, good job. Okay, Skylar, what did you get? Awesome. Y equals plus or minus 3.32, you said, right? Good. So the first thing you should have done there was add 5 to both sides, and then divide by 11, and then square root both sides. So you ended up with this y squared equals square root of 11. Does anyone need me to go through that? Thumbs up, thumbs middle, thumbs down so far. Okay, thank you. Okay, let's look at letter R. This one's pretty easy, but we'll just do this together. Okay, letter R, kind of like the first warm-up that you did. A square book cover has an area of 400 centimeters squared. What is the length of each side of the cover? So this is easy. Go ahead and do that. The area of the book cover is 400 centimeters squared. They tell you it's a square, so your book must be a square. What is the side length of the cover? When you think you have it, raise your hand. Steve, what'd you get? Nope, careful, not 100. The area is 400. Neil. Peyton? Good, how'd you get 20? Good job. Area is equal to 400 centimeters squared. You know the formula for area is area equals side squared. So really all you were doing and all you were thinking through is 400 equals side squared. To solve for side, square root both sides. You get the side is 20. Now in this one, centimeters, can you have an answer that's negative? No, your book cover cannot be negative dimensions, right? You can't say, my book cover is negative 20 centimeters in width. Can't say that. So in this case, you only have one answer. Questions? Mike? Wait, it said you had 5% of negative 2%? Is that what you just said?
Yeah.
Right. Then maybe you did something wrong. Because that's not right. I would try that again at some point. And I'll have to look to see if I have something, because that's actually, that would go along with this lesson a little bit. Okay, let's do the closing, part of it at least. Okay, so the closing says, in science, you can use the formula 16 times time squared, which equals the distance, to find either the height of an object or the amount of time that it will take for the object to fall to the ground. Use this formula to answer the following questions. So our formula is distance equals 16 times time squared. So what I want you to do is for 20 feet, 40 feet, and 80 feet, I want you to plug that in. You need to find how long the baseball is going to take to fall if you drop it from that height. And then the question that we're going to have a small discussion on is, as the height doubles, does the falling time double? So take a couple minutes. Shouldn't take you long. Use your calculator for the first 3, and then think about the pattern or how they are related. What's wrong? What are you doing? You need to start. You should be just about done. True. What are you doing? Why are you confused? This is the distance. Look at the formula I wrote up there. You're plugging 20 in for D. So you have 20 equals 16t squared. Solve for t. You need to write that down, okay? Just like we did over here. It's very similar to this problem. You didn't even write that one down. Those are not right. Did you divide by 16 on both? Okay, divide first. Okay, I'm going to start going over the first one because I think some of you are making silly mistakes. So here's how you set this up. 20 is the distance, so that must be the height that they are dropping the baseball from. So 20 equals 16 squared. How do you get rid of the 16? Amberly? Good. Divide both sides by 16. So you end up with 1.25 equals t squared. So what is the time from 20 feet? Kevin? Good. 1.12 seconds. Kevin, can we use our negative answer here? Or should we just have a positive answer? Yeah, just positive. Even though the ball is decreasing, you can't say, you know, the baseball dropped in negative 1.12 seconds. Just like saying, I ran for negative 1 hour today. So you need to make sure you're keeping time positive. Okay, what is the time if you drop the baseball from 40 feet? Kevin? Good, 1.58 seconds. And Jackie, how about from 80 feet? Say that again? I just couldn't hear you. Good job. 2.24? Is that what you got, or 5? 4? Good. Making sure I rounded correctly. So 2.24 seconds. Does anyone need to go through how to solve to get any of that? So those of you that were confused, are you okay now? Okay, so for letter T, as the height doubles, does the falling time double? What's the answer to that? Camille? No. What does it do? Say that again. Pretty close, yes. Actually, yes, it does. But what does it do from 20 to 40 and then 40 to 80? Not double, but, Mike? Nope. Peyton? Think about what it multiplies. It doesn't double, but it multiplies. Peyton? 1.5 or 1/2? Oh, should be by 1.5. So it really is 1.5 times, instead of doubling, it's really like 1.5 times. So if you take 1.12 and multiply it by about 1.5, I think it was exactly 1.4. You guys can check me to make sure. So it's not quite double, it's a little bit less than that. Someone check me to make sure that 1.12, Amberly, what'd you get? Okay, so pretty close. Yeah, I figured when I divided it was about 1.4. Figure if we round that up, it's about 1.5 times more as the distance doubles. Okay, so if you see a problem like this on a quiz or test, are you okay? Okay. Homework, so open up your homework packet to the very first page. I want you guys and girls to try practice 9.1 for homework, and I want you to do all of them. It's not bad. You will probably need to borrow my calculator if you have it, so make sure you have your number. Please be careful with it, because again, I only have that class set. When you're solving an equation, make sure you have plus or minus as your answer, if it makes sense for that scenario. And the square root ones, when you're taking the square root of it, it says to approximate, so you can round to the nearest integer on there. 13 through 18, those are the ones that you should write down, whether it's a perfect square and then rational or irrational. And I'll ask you that tomorrow just as a review. Okay, any questions? Tomorrow's lesson, when you first hear it, is definitely more difficult than some of the other lessons we've done this year, so make sure you're ready for that tomorrow. We'll spend a couple days on simplifying radicals by hand, which means without the calculator. Okay? Any questions? Okay, you guys can get packed up. Let me see who's first today. Boys are first today. So if you need your calculator, you might want to take it. Just be careful with